Hi guys, in this video I am going to prove an important theorem in real number system, that is Archimedean property. It states that if x and y are real numbers, x greater than 0, then there is a positive integer n such that nx is greater than y. So let us go to the proof. What they have given is y is any real number, x is any positive real number, and n is any positive integer. Then we have to show that nx is greater than y for some n. For this, let us consider a set A. The elements of the set A are the product of elements of positive integer set and the elements of positive real number set. That is, n is a positive integer and x is a positive real number. We know that positive integer set is a non-empty subset of R, and the positive real number set is the non-empty subset of R. Therefore, its product is also non-empty subset of R. Therefore, A is a non-empty subset of R. Now we have to show nx is greater than y for some n. On contrary, let us assume that nx is less than y for all n. Since every element of A, nx, is less than an element of R, that is y. So, we can call y as the upper bound of A. In other words, we can say A is bounded above. A is bounded above and A is a non-empty subset of R. From completeness axiom, what does the completeness axiom say? It says that if A is a non-empty subset of R and A is bounded above, then the supremum of A exists in R. So, let alpha be the supremum of A in R. Now, x is greater than 0. We know that x is greater than 0 and alpha is the supremum of A. Therefore, alpha minus x is obviously less than alpha. Since alpha is the supremum and alpha minus x is less than alpha, then alpha minus x is not the upper bound of A. Since alpha minus x is not the upper bound of A, there exists some element, say mx, belongs to A such that alpha minus x is less than mx. So rearranging this, what we get is alpha is less than m plus 1 x. Since m is an integer, so m plus 1 is also an integer. So this m plus 1 into x belongs to A. An element of A less than its supremum, which is impossible. Therefore, which is a contradiction to the fact that alpha is the supremum of A. This contradiction has arisen due to our assumption that nx is less than y for all n. Therefore, our assumption that nx is less than y for all n is wrong. Hence, we can say that nx is greater than y for some n. This is what we needed to prove, and hence the property and once again the statement, if x and y are real numbers, x greater than 0, then there is a positive integer n such that nx is greater than y for some n. Thank you.